good morning. Hello, this is Aurora with Supercharged Science, and today we are going to be starting our dive into alternative and renewable energy. And before we get started, I just wanted to give a quick shout out to anyone that wants to type in and say good morning. Go ahead and use your fingers on the comment box right now, and I will give you a quick hello. Now, just to recap what Supercharged Science is and what we've been up to while everyone is jumping online, Supercharged Science, we are a science curriculum homeschool, I've got kids at home, help teach them for me, publishing company that creates science curriculum for K through 12. So we have everything from kindergarten all the way up through high school. And we've been doing this since 1999. Actually, we got started doing live science classes throughout the area, doing science workshops and science camps and that sort of thing. We focus mostly on the areas that teachers generally have a tougher time with, and that includes physics and chemistry. So those are the two where we really got known for. We would launch rockets, we would do laser light shows, we do electronics, and the teachers in our area were more than happy to say, great, go ahead and teach them all. So I used to teach mechanical engineering at Cal Poly State University, and I did graduate studies both in mechanical engineering at Cal Poly as well as Stanford. I was in the high temperature gas dynamics lab. And I share this with you because when I was teaching at the university level, I quickly saw what was coming in and realizing that kids were not getting what they needed in order to handle the workload. In fact, I was really surprised when I read not too long ago, I think it was in Forbes magazine, that 60% of incoming engineering freshmen either drop out or they change majors the first year. 60% is huge. Now, when I was a mechanical engineering undergraduate, when I was a little freshman, there were 350 students in that engineering degree program, and only 4 were women. And only 2 of the women graduated, and I was one of them. One of them later went on to like a software job or something like that. So it's a hard major, and we want to make sure that you guys can handle it once you get there. And once you do, it's amazing. So we want to get as many kids crazy wild about engineering and about science as possible, because a lot of those, the top 2 reasons, remember I shared that 60% of incoming engineering freshmen drop out. There's actually 40% drop out, and the 2 top reasons are they didn't think they could handle it, they didn't think they had what it took to handle it, or they got into the major and realized, ooh, that's not quite what I imagined it would be. So both of those things are preventable, right? Especially if you expose your kids when they're younger to engineering. Okay, so it looks like we've got a number of folks online. So welcome, I'm Aurora with Supercharged Science. We are saying hello to Carla and Caleb in Rhode Island, and we have Lauren and Natalie from Washington. So hello, good morning. We have Oliver from Montana. We have Layla from Minnesota. Oh my goodness, we have a lot of people from Minnesota. We have Gavin and Mom in Oregon. And we also have a request for more volume. How's that? Is that a little better? I want to make sure we don't overmodulate there because that's no fun. Okay, and we have Charlie and Nolan from Minnesota. We have Daniel and Hannah from Washington. So welcome, welcome. Let me know if the audio is better. Is that better? Okay, so we are going to get started in our renewable energy class. We've got a number of different things we're going to be doing. We had so many students ask, what are batteries? And so we're going to start there, and then we're going to keep it going. So we are going to talk about renewable energy, everything. What's renewable energy? Tell me out loud. Come on, pretend like you and I are having a conversation. I can totally hear what you're saying. You can talk right over me. It's totally fine. Tell me, what is renewable energy? You got 10 seconds. Ready, set, go. What is it? What do you think? What do you think? What do you think? I'm adjusting my microphone here so as you're talking to me. Okay? Yeah, so did you mention maybe battery free? Yeah, so what are we doing talking about batteries? You'll see. Okay, what else? What else did you mention? Let's see. Okay, how's that? Testing, 1, 2, 3. Is the sound better? Okay. Okay, good, good, good. Okay, it's better. Okay, good, good, good. All right, so renewable energy, what is it? What did you tell me? We're still saying hello. Okay. Okay, so typically when people talk about like the gas you put in your car, that's not what they're usually referring to. They're usually referring to something that has a low footprint. It's something that doesn't usually pollute a lot, and it's easily replaceable. Things like wind energy. Wind's going to be there whether we use it or not. But wouldn't it be great to be able to turn a propeller or blade and harness that energy? Actually, I'm going to share with you later this week about these turbines. You know, we get wind power. You've seen wind turbine farms. They've actually figured out a way that as those blades go through the air, they also capture the humidity, and it runs along on the inside. So now wind turbines are being repurposed for using, they're still in the prototype phase, but they're being repurposed to generate clear drinkable water by condensing the water molecules that are already in the air, in addition to providing electricity from the wind itself. So there's a lot of really new, cool technologies out there that are being developed. In fact, if you've been keeping up with the news, you know that two girls, a 16-year-old and a 17-year-old, not on the same team, but independently, figured out ways to create jet fuel from algae. And the Air Force is starting to use technology like this. So you don't have to be, anybody really can be developing stuff like this, which is just amazing. Okay, so we had a number of questions before about, what are batteries? So I thought this would be a really cool experiment. So if we get enough time, we'll do all three. I know I only gave you materials list for 2, but the third set of materials, it's easy to get. Okay. So you can do this whole class with 0 materials at all. Everybody put a big old grin on your face and say, oh yeah, if you're ready to get started. Okay, so what are we going to be learning about batteries? I actually have a couple of slides for you, but the first thing we're going to do is we're going to listen to we're going to listen to electricity, and then this by making a battery out of tin foil, a penny, and ketchup. Then we're also going to, which sounds ridiculous, then we're also going to do you have a piece of silverware, like real silverware? Not the stuff you use every day, but like grandma's silverware. Now, have you ever had the job of polishing that stuff? It's like really, it's a tedious job. Like nobody ever likes to do it. So what we're going to do is we're going to actually take a piece of that silverware that you really don't care about, maybe like the butter knife or something. Don't try it on like one of the big pieces yet, but take one that's really tarnished, and we are going to turn that into a battery, and it's actually going to wind up polishing it for you, and it'll come out really, really clean. It'll be all sparkly and everything. So that's the second one. That's called the silverware car wash. We're going to turn that piece of real silver into a battery. And then the third one is you can shock your parents with a lemon, and I will show you how to do that. Okay, you ready to get started? So here we go. So the first thing, now science isn't, again, you've heard me say this before, those of you who've been around the block, science isn't about what you know. I'm not as impressed with, kids that can, spit out all these factoids. What I am impressed with is their ability to handle questions and ability to ask questions. That is what makes me go, ooh, that kid's going places. So what do I mean by that? So I could teach you how to make a battery, but instead I would rather ask you a question and see if you can design an experiment to answer that question. So that's what we're going to be doing today. So the first question I have for you is not what is a battery, because anybody could look that up. But we're going to take a look at how a battery can be used to store energy. So our question is going to be what kind of, well, we're going to get into it, and then you'll see where the questions are going to start to pop up. Does that make sense? So we're not memorizing anything. We're learning how to think, how to process information, and how to look at the world around you and design experiments to get those questions answered. That's what science is at its core. It's not some AP test you have to take to prove that, yes, you memorized a whole bunch of stuff about the inside map of a cat, the anatomy of a cat. Not as impressive as it is for a kid that can design something just by being curious around them, about the world around them. Okay, so how do we investigate this battery thing? So what are batteries? Tell me out loud. What do you think they are? And then let's talk about that. Go ahead. I'm going to get my slides ready while you're telling me what they are. What are batteries? Go for it. Come on, tell me more. You know more than that. What are batteries? Okay, so a battery is a device. Here, am I showing my slide? Yes. Okay, so a battery, did you say it's a device of some kind? Sure, that stores what kind of energy? It stores chemical energy, and it converts it into what kind of energy? That's right, electrical energy. Okay, so there are chemical reactions that go on inside of a battery that involve the flow of electrons from one material, one electrode, to another through a circuit. So if you just put a battery in here, nothing's going to happen until you actually hook things up. These are the places you would be hooking wires up and so forth. So it's the flow of charge, the flow of electrons that provides the current that we can use to do work, which could be, you know, turn the motor, or like all the experiments we did last week, right? When we were working with propellers and buzzers and that sort of thing. Okay, so so basically that's what we're going to be focusing on here. How a battery does that. Like, how does it do it? You just can't take a block of wood and call it a battery, right? You need a flow of charge to happen. And in order to do that, you need a couple of components to the battery itself. Now, you can see these are kind of like a dull silver. What if one of these was gold? Would that work? Well, I don't know. That's part of our questions we're going to start to ask. So different electrodes, these are the electrodes, the metal bits that stick inside this acid that's inside. The different electrodes and different electrolytes, like the acid inside of a battery, produce different chemical reactions, and that will affect how the battery works and how much energy it can store and how much voltage you can get out of it. So not everything's going to work. If you were to replace the acid inside this battery with, say, you know, sugar, like maple syrup or sugar syrup or something like that, it's going to work very differently than if you replace it with sulfuric acid, for example. It's all in the chemistry. So basically, at its core, no pun intended, a battery is something. It's just a box that has chemical reactions going inside. You can tap into that, and if you hook up a circuit, hook up a light bulb, now that flow of charge is going to keep going. But what happens inside the box? Okay, let's take a look. So most batteries contain two or more different chemical substances, different molecules inside. And usually they're separated by a barrier, so they can't mix all together. Otherwise, the battery would be over in like 2 seconds. So on one side of a battery, it's going to be like the positive terminal. On the other side, it's going to be like a negative terminal, okay? Makes sense. When you see a battery, you see like a button on one side, there's your plus, a flat side on the other, right? Okay, so normally when that battery is just sitting there, the reactions going on inside, it will slowly start to react with itself, but that's why if you put it in the fridge, it will slow that process down, or the freezer, and so your batteries will last longer. But typically, not a whole lot happens until you start to connect those wires. Okay, so how does it do its thing? All right, so you know, if you've ever taken like a glass of water and you put some sugar in it and you stir it up, no matter how much you stir, especially if that water's really cold, you tell me, where does most of the sugar wind up? You ever tried to make lemonade? Where's most of the sugar? It's at the bottom, right? So sugar, when it puts in there, it stays as the sugar molecule. Now, there are some things that when you put it in there, like salt, it will start to break apart. So the salt is made of two different elements. It's made of sodium and chloride, so regular table salt. When you put it in water, some of that sodium chloride just naturally will come apart in the water. Now, sodium is going to have a plus. Okay, wait here. So sodium is going to have a plus, and chloride is going to have the, say it out loud, it's going to have the minus. All right, now put your hands out in front of you. Do you remember we talked about magnets? If I have a plus and a plus, pretend your two hands are magnets. If I've got a north and a north side, show me what happens. Yeah, they don't like to go together. What if you have a north and a south? That's right, they go together. What if you have a plus and a plus? They don't go together. What if you have a plus and a minus? That's right. So if I have in that sugar water, if I stick something in there that's positively charged, what is going to be attracted to it? The negative, right? And if I stick a negative over here, are the negatives going to be attracted to the negative? No, it's the positives. Okay, so imagine I've got that positive one in here. Now, all of a sudden, all the negatives are being attracted to it. And now we have a motion of electrons, a flow of electrons through this cup of salt water. And that is what starts our charge. And if these two wires are connected on top, now we've got a battery that can actually happen. So I can drive the reaction by having a battery up here and energizing these two. So I've got a plus and a minus plate. You know, the two little, it could be, they could be like a paper clip, they could be a copper penny, they could be anything for your electrodes. Two metallic pieces, it could be two pieces of carbon, like two pieces of a pencil, could be in there. So if you connect those plus and minus to your pencils, now you've got a plus pencil and a minus pencil, right? And now you can start to get a flow of electrons. That flow of electrons is what a battery is all about. So as soon as you have that flow, now we can have electricity happen in our circuit, right? When there's no flow, nothing happens. So check this out. If you want to, do you want to shock your parents? Come on, say yes. Okay, let's do this one first because I'll probably forget later. Okay, so imagine you've got a lemon in your hands. Can you imagine that? Stick a lemon in there. Okay, now squish it up. Squish, 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 squish. No, don't squish it so much that it like busts apart and is leaking, but squish it enough where you know those sections on the inside, like if you cut a lemon in half, there are all these little triangles in there. You want to kind of make it so those triangles, those membranes burst open, so it's all one great big lemon inside, not all these little triangular sections. So you know, kind of just mush it up in your hands. Now you're going to stick two things in there. You're going to stick a copper penny and you're going to stick a nail. No, if you don't do that right now, just imagine. Or you can pick any two materials. What other two metals do you have in your house? Do you have like a shiny brass key? That would work as well. What else? What other pieces of metal do you have in your house? Yeah, how about aluminum? Do you have any aluminum? I bet you do. You could stick that in there as well. So you want to put one in each. So draw a picture of a lemon right now. Go ahead and draw a picture of a lemon. And now you're going to put one piece and another piece, but make sure they don't touch inside. And you're just going to put them partway in. So what does that mean? That means that as soon as you put them partway in, you've got one metal and another metal, and they're inside of something that has an acid, something very acidic. That acidic stuff is going to react with the metallic stuff. And if these two are different, you should try them with the same, but if they're different, and you go up to your favorite parent, so now you've got this lemon with like a key and a paper clip sticking out of it, and it looks very suspicious, and you go up to your favorite parent, and you're like, not your favorite, you go up to the parent that you think will actually say yes. That's the parent you want. And so you go up to them with this lemon that's got these two things sticking out, and you say, hey, I'm doing a science project. Will you help me? And this parent's like, sure, I'd love to help you. What do you need? And you say, okay, here's what I want you to do. I'm testing this out. I want to know, when you stick your tongue onto both contacts at the same time, do you feel anything? And then just hand it to him. At this point, the parent's like, I'm not so sure. You say, it's okay. It's totally safe. Miss Aurora told me it was totally safe. You won't get hurt. I just need to know what your reaction is going to be. And you just sit there and you watch. As soon as their tongue or finger or something touches it, they will complete the circuit because you've made a small battery. Isn't that cool? Okay, so that was homework assignment number 1. So, and if you chain together a whole bunch of lemons, you will be able to light up, oh, well, it's actually going to take about 80 lemons to light up a real light bulb, but you can light up an LED, I think 17 or 18 lemons will be able to do it. And you see you've got two dissimilar metals here, metals that are different, and you've hooked them up. Okay, so let's get back to, we are going to talk about how to make a battery out, or how to hear electrons by using foil and using a splat of tomato sauce or ketchup and a penny. Are you ready for that? Okay, so if you got your materials out for this class, you want to go ahead and grab them. You can actually do this experiment with me. We're going to do it pretty slow, and so you can go through it. Now, if you don't have any materials at all, no problem. All you have to do is grab a sheet of paper and a pencil and just make a few notes so you know what to do once you get your stuff. So again, today's experiment is really super simple. And if you do have those earbuds, we actually are going to be clipping right into it so you can hear it yourself. So we're not going to plug the earbuds into anything. We're actually going to, I'm going to show you how to hook it up so you can actually hear what's going on. Okay, you ready? Okay, so let me grab my slide. Give me just a second. Okay, and here we go. Let's start it at the beginning. We're going to take a look at whether a battery can be used to store energy. Now, to do that, you're going to need some tomato juice. You're also going to need a headset or earphones, the kind with a plug. Okay. You're also going to need a battery. If you have any size battery you have at home is fine, as long as it's a AA, a C, or a D. You're also going to need a couple of alligator wires, a spoon, shiny penny, some aluminum foil, and a plate. Okay, so the first thing we want to do is take a look at the earphones. Do you notice how my earphones have two little spacers here? Yours may only have one, depends on the type of earphones you're using. But whether you have one or two, the hookup is still the same. You want to grab on one side of the spacer, and then you want to grab on the tip. Okay. So this is the plus and minus part of a plug. So let's test to make sure this is working right. What we want to do is you actually want to put these on and take the other two ends, okay, and go ahead and put one end to each side of a battery. don't leave it on there, but just kind of touch it just like that. Just tap it, and you should hear a crackling noise. If you hear the crackling noise, that means you got your connections over here right. If you don't hear a crackling noise, try it again. Your next step is to put a square of... Let me pause right there. Let me pause right there. So notice I didn't leave it on. I'm just touching it just to make sure that it's working, that I got these connections right. If you want to see those connections again, let me show you. See if I can stop it. Ooh, it's a little out of focus there, isn't it? Okay, so basically we're connecting onto the base here, and we are also connecting onto the tip. Okay, now if you only have one band, it'll still work, or if you have three bands, it'll still work. Just do the tip as well as the base. You got it? Okay, and then just touch it with your battery. Touch, touch, tap, tap, tap. Okay, and then that's just to make sure that you've got this correct. Okay, now we're going to make a battery ourselves. You ready? Okay, here we go. To each side of a battery. Don't leave it on there, but just kind of touch it just like that. Just tap it, and you should hear a crackling noise. If you hear the crackling noise, that means you got your connections over here right. If you don't hear a crackling noise, try it again. Your next step is to put a square of aluminum foil on your plate, and then place a small puddle of tomato juice on your foil. You want this puddle to be a little bit larger than your penny. We're going to put the penny on the tomato juice. Make sure it's a shiny penny. Okay, and you're going to clip one wire onto the aluminum foil, and you're going to touch the other end of the wire to the penny. Kind of move it over the penny. Do you hear that crackling sound when you touch the alligator clips to the penny in the puddle of the tomato juice? What do you hear when you move the alligator clip over the penny? What about if you stop touching the penny? So a battery is a device that makes electrical energy from a chemical reaction. And another name for a battery is a voltaic cell. Voltaic means to make electricity. Now, most batteries inside, they contain different chemicals to create that electricity. The different chemicals are separated by a barrier. On one side is the positive terminal of the battery, and the other side is the negative. When we connect the plus and minus, we actually have a circuit, and the chemical reaction takes place between the two different substances that make a flow of electrons, which is electricity. When a battery is producing electricity, one of the chemical substances in a battery loses electrons, and those electrons are gained by the other substance. Now, in this experiment, we just made a simple battery with the penny, the foil, and the tomato juice. We completed the circuit of the battery by touching one of the wires to the penny and the other wire to the foil. When we completed this circuit, you're actually hearing the flow of electrons by that crackling sound that we hear in the headset. Now, in this battery, the aluminum in the aluminum foil is the one that loses electrons, and the other part of the reaction is actually kind of complicated. Either in the acid of the tomato juice or the copper ions that form when the penny reacts with the tomato juice, those are the ones that gain the electrons lost by the aluminum. What happens if you try other coins like a dime, a nickel, or a quarter? Do any of these coins make a louder crackling sound? What happens if you use a nail instead of a coin? And what if you try orange juice instead of tomato juice? What about lemon juice? What other kind of juices can you make a battery out of? Go ahead and give that a try. So what do you think? Does the main part of the experiment make sense? So that's what we're really after. Notice that I just didn't say step 1, step 2, step 3, and then get this result and do this. I gave you a model, I showed you an experiment, and then I said, hey, there are 10 other variations at least that you can do. I didn't even mention temperature. What happens if you heat up the tomato sauce first, or if you cool the metals down? So there's a lot of variables in here. Your job now is to go and see which one gives you the most crackly, the highest volume of crackly that you can feel. If you actually have a digital multimeter, use that instead of the instead of the audio, but I thought most people had a set of headphones and not a digital multimeter. So that's why we're doing this particular experiment. Okay, so I'm gonna show you the silverware car wash, and this will be the last one we do since we already talked about the lemon. The lemon is the same idea as the ketchup, only it just looks different, right? Because you're accessing the lemon and you're putting two metals in. What were the two metals in the experiment that I just showed you? Yeah, they were aluminum. What else? Tell me out loud. They were copper, right? If you have a penny that's minted before 1982, that penny is going to be pure copper. If it's after, it's going to be an alloy. It's going to have a lot of other things. So you want to check both kinds of pennies. You want to check the ones before 1982 and after 1982. Isn't this cool? There are tons of things you can do with this one simple experiment. Okay, you want one more, or is that enough? What do you think? One more? Okay, we can do one more. One question I was getting is, can I use ketchup? My answer is, I don't know. Try it. See what happens. Is there a difference between ketchup and tomato sauce? Do you notice a difference? So it'd be really cool if you could record your audio findings, and that way you can go back, and because it's a little subjective, you're like, oh, that was loud. The next one you're like, well, that one was loud too. That's why having a measuring device like a digital multimeter would actually be a good thing. Okay, if you want to get scientific, but this is just the, ooh, wow, look at this. Isn't this cool? You just made a battery that you can hear. I mean, how many people have ever done that experiment? Okay, so imagine your mom gives you the assignment today, and you're like, you can go play as soon as, you know, all the silverware is polished. So I remember having that as a kid, and I hated this job. So being a young budding scientist that you are, you say, no problem, Mom, no problem. In fact, why don't you just go relax? I'll handle it all. And what you're going to do now is you're going to sneak into the kitchen and you're going to make a battery. And when you're done, you just simply, you pull it out of the solution, wipe it clean, and it is completely done. Now, again, don't use this with grandma's, like her really good stuff, but you do need a piece of real silver that's been tarnished. Now that black stuff that's on there, that tarnished part, that's really the sulfur that came from the food. So what we're going to do is we're going to put it in a solution that will actually take the sulfur off, break it apart. It actually will take the silver and the sulfur off because they're combined. That's what the black stuff is. And then they're going to break them apart, but then we're going to we're going to charge the electrically charge the spoon, so the silver gets attracted and redeposited back onto the silver spoon. So we're going to take the stuff off, break it off, leave the sulfur, and it's going to get deposited on the foil, and then put the silver back on the spoon or whatever, the silverware itself. Okay, you ready? Here we go. Let's see, I thought tomato sauce and ketchup were the same thing. What I would recommend, Liam, is taking a look at the ingredients on the back, and you tell me if your ketchup is the same thing as tomato sauce. Okay. Let's see. It looks like, let's see. It looks like we are still looking for our video. Give me a second. Here we go. Okay. So you ready? Okay, so again, this is not one you're going to be able to do as I'm talking about it. You're going to want to write this one down, and it's really, really simple. So the materials for this one are, write this down, you're going to need aluminum foil, so put foil. You're going to need water. If you want to write that down, you can. Baking soda and salt. So 4 things. You'll need foil, water, baking soda, and salt, okay? And you need, of course, real silverware. Now make sure you're not using stainless, because if you use stainless steel, it's not going to work. Okay, so here we go. You guys ready for this one? Ready, set, go. Battery. Are you ready? So into a regular pan, go ahead and line it with foil. And then place about a cup of water into your pan. Now, if you have a large pan, you might want to double this recipe. Add 1 teaspoon of salt and 1 teaspoon of baking soda. Go ahead and stir it around, and then heat the mixture until it begins to boil. When the mixture is near boiling, place your tarnished item into the liquid. What's going on with this reaction anyway? Basically, the tarnished part of your silverware is sulfur, and what's happening with this is the chemicals inside are taking the silver and the sulfur off your spoon and putting the sulfur on the foil and the silver back onto your silverware. So any part that's exposed and not touching the aluminum actually won't get clean. So if we flip this over, the handle can make a better contact with the foil itself. When it's done, simply lift it out, rinse it under water, and wipe dry. There we go. Did that go by too fast? Okay, so all you do is you line your skillet with foil, and then you just add your water and some baking soda and salt, and just throw a couple of tablespoons in there, maybe even as much as a 1/4 cup. And then you kind of stir it around, heat it up, and put the silver in it. So you're just putting everything together, and you're making a battery. We're adding heat to it to kind of drive that reaction to really make sure it gets all around. So any part of the spoon that's touching the foil is going to be able to experience this. Now, if you really want to get fancy, you can wrap your spoon in the foil, another layer of foil itself, so it's like covering completely. So there you have it. You got several different experiments. You've got the lemon battery. And by the way, if you try the lemon one and it doesn't work, make sure you've really squished it inside so it's really a juicy lemon. You don't have to just try lemons. You could try limes. You could try grapefruits. You ever seen those big pomelo things? You could try those as well. Try anything that is citrus-like that will have a high level of acidity inside. Give that a try. And if you're finding, hey, that doesn't work, then you could stick it in the microwave for 5 seconds and see if you could heat it up to try to make that reaction happen the way we were doing with the silverware one. You can also try different types of metal, because different combinations of metal are going to give you a different level of voltage. So you could try, brass and aluminum. You've got steel, you've got iron, you've got lots of different choices, right? You've got copper with copper pennies. There are lots of different opportunities here. You've got hairpins. Just make sure that it's actually the metal. It doesn't have like a clear coating or enamel on it or paint, because that will keep the charge from flowing. It's like insulation. Okay, so hopefully you guys have several different experiments to do now, yes? Okay, your job is to make sure you go out and do those experiments, and then take pictures of yourself and send them to me. Tell me what you're doing. And if you'd like, you just kind of let me know which one of those experiments that you like the best. Go ahead and try that now. You're going to make your own batteries at home from tomato, ketchup, tin foil, baking soda, salt. You've got the basics for 3 different ones. I hope it wasn't too confusing giving you all at once. Okay, parents, so a couple of the secrets that we did today is we didn't give away the ending. We gave them enough information so they see where to go, with enough variation where they can start to change things. And now this is going to trigger more questions like, ooh, what happens if I double the vinegar? What happens if I use vinegar instead of water in the silverware experiment? Again, don't use your best silver if you're going to be doing experiments like that. So what happens if I use baking powder instead of baking soda? So there's a lot of different questions, and you can safely experiment within these parameters. Does that make sense? So again, my name is Aurora with Supercharged Science. If you like this and you want more, there is a link down here. Check out our online school where I can teach your kids science all day long like this, and they will stay happily engaged. Tomorrow experiment, we're actually going to do a little bit further in chemistry. We're going to talk about endo and exo reactions. And then on Wednesday, moving forward, we have more renewable energy projects. We're going to be making solar cookies. And on Friday, did I tell you about Fridays yet? Oh, this is so fun. We've had so many parents call in, mostly dads, say, I want to do projects with my kids too, but I'm working all day. So we decided on Fridays we would make those projects much more involved. We started last Friday with a couple of days ago, with the Crystal Radio Project. So dads, or moms too, hey, I'm a mom and I do these kinds of projects, so it's up to you. So parents, if you would like to do projects with your kids over the weekend, those will be released on Friday. You can do them with us live and ask questions as we go, or you can save them and watch them over the weekend to do with your kids. So those will be much more involved. We'll be making steamboats on Friday. Yes, with real steam. You can see why this is not just a kid project. You do want parents for this one. There's going to be fire involved. So we'll be doing those on Friday. So we have a bunch of really cool projects coming up. If you're in a baking mood, save it for Wednesday, because Wednesday you'll actually get to eat your assignment that we actually put together. Okay, if you have questions, make sure you let me know, Aurora at superchargedscience.com. And feel free to check us out, superchargedscience.com/school. There's like a website around here somewhere that you can take a look at. And and I'm happy to teach your kids like this all day long, every day, just day after day after day, even through the summer, even through the fall. So I look forward to seeing you tomorrow. And if you have questions, make sure you let us know. You can write them in the comment box right now. Go ahead and take your fingers out, kids. Your last assignment is put them on. Which one of the 3 batteries did you like best? Go ahead and tell me right now, and then I will see you guys all next time. Thank you everyone for joining me. So kids, tell me right now, which one of the 3 did you like best? Ready, set, go.